So we can take out a 2, and we're left with the square root of 5. So my final answer is 2 square root of 5. So if you understand these 6 problems, especially the last 4, the first 3 are just set up so we can get the idea. If you understand 4, 5, and 6, those are the kind you're going to see on the TSI. And if you get that, that should make you happy because it's something that you should definitely be able to do. And again, it's just pure mathematics. You don't have to think about a word problem, or you don't have to decipher anything. You just, okay, here's the Pythagorean theorem. I know I'm going to square, add or subtract, take the square root, and possibly simplify the square root or square a square root. But those are all things you can do with practice. So you can do the ones in the bottom, and you can see there's 1 through 6. So the first 3 will come out to be all whole numbers. 4, you have a side that's a square root. And then 5 and 6, thank you, Jacinta, I see your back. You're going to get an answer that's not a perfect square. You have to simplify. So as you do these, let me know if you have any questions, and we'll go through it step by step to make sure you understand it. So I don't know if, I'm not sure if I told you at the beginning, but a lot of times I recommend students have note cards. You can buy those spiral note cards, the 3x5 index cards. They have a spiral one, or you can keep them all together. And you can start putting notes and formulas and things in there so you can review quickly. And that will be good. If you go on in math, you can always go back and review some of those things that you're going to see again. And so this is one of the formulas that you want to remember and put in there. No quiz today because we haven't done enough topics to do the next quiz. But like I said, on the solving equations, that's one that you definitely want to at least have in the 90s or 100. So you might want to consider retaking that quiz. And so next week is going to be mostly all geometry. And if we can get in some probability and statistics, that'll be good. But after that, you should be able to know how to do more questions. A 91, no, if you got 91, that's good. I was just saying, if you had less than a 90, you probably wouldn't retake it.
Okay, thank you so much.
You're welcome. But hopefully you have more techniques that so we usually encourage you to try to take it right after the 4-week mark. just to see where you're at, and you want to see that we increase in scores, and then we still have 4 more weeks to go, but a lot of times students get complete and you're done. But if you still want to keep working, you can still stay in the class, but at least you're complete.
You do three, one.
Number 3, yes. Let's go to the blank page so we can look at it. Make it a little bigger. Okay, so did you identify where the L was?
Yes.
Okay, and
So
so
it's
what do
A
you call it?
Oh, A squared.
So this would be A,
That's B.
and this is C, right? So these sides aren't A squared and B squared, they're just A, B, and C. When we put them in the formula, they become A squared, B squared, C squared. So do we know A?
No.
And what do we put for this one?
80. 80 squared and 82 squared.
Okay, and then when you squared 80, what'd you get?
I have my calculator out. 6,400.
Okay, and when you square 82,
6724.
okay, so we squared the two numbers. Now we want to solve for A squared, so am I going to end up adding those numbers or subtracting them?
Well, you're gonna subtract 6,400 from both sides.
Right, because we're solving by opposites. These cancel out, and so A squared equals, that'd be 324.
Right. Now that's where I kind of got stuck. So we're gonna square both of them, and the squares cancel out.
Oh, no, okay, wait, so we have A squared equals 324. So now we don't want to square, the last step is find the square root.
Right. So they cancel each other out as far as.
Yeah, so the square and the square cancels out and I get A equals, and in our calculator we want to do what's the square root of 324?
Now my calculator doesn't have this, so we're.
Okay, what kind of calculator do you have?
I'm using my phone right now.
Okay, turn your phone sideways and then you should see more. It didn't turn to a scientific?
Yeah, you know what? It didn't even turn to the side. I'm working with an Android.
Okay,
Yeah.
I see. Hang on.
Let me see. Okay, there it goes. I turned it to the side. Okay.
Okay, and
So-
then what's the square? What is the square root of 324?
So do we do the square root sign first and then 324?
On that calculator, well, let's see. Put it in there and then do 324. If it says 324, then I have to do it backwards.
Okay. When I did the square root sign and then 324, it came out to 18.
That's the correct answer. So good.
Okay.
So that missing side
It's
turns out
out
to
to
be
18. Okay. I didn't know my calculator could do that.
So there's that scientific part, but on the TSI, all it does is add, subtract, multiply, and divide, and then sometimes there's a square root key. There's no plus or minus key. There's no extra power key or anything. But on here, if I want to find the square root of 324, I would put 324 and then hit this key, and now we get the 18.
Okay.
So keep that in mind when you take the TSI.
All right. Thank you.
When it says computer calculator is better, you can also find calculators online and use those. But keep in mind that the TSI calculator doesn't do anything extra. All it does is add, subtract, multiply, and divide. And sometimes the square root key is there, not always. It will only be there if there's some sort of square root in the problem. Doesn't mean you have to use it, but it's there in case you need to use it for some reason. And also the biggest thing is there's no plus or minus key. A lot of students think that subtraction key acts as a negative key, but it doesn't, and it messes them up. So if you have a fraction equals to a fraction, that's a proportion. And the numbers at the top have to be the same type of number. So whatever these are, they have to be the same kind of units. Like if you have time, both the numbers on top have to be time. If you have something like they're making so many, like they make like 4 machines in 3 weeks. So the machines would be the bottom, weeks in the top. Those top numbers have to be the same kind of thing. And you'll see when we do problem number 1. And to solve, you cross multiply and divide. So we'll do a quick example. So here's a proportion, 2 over 10 equals x over 20. Once we set it up, the solving seems to be pretty straightforward for most students. All we do is we cross multiply and divide. And so what I mean by that is we're going to cross diagonally, and we're going to multiply the diagonal that has the x in it first. So 10 times x is 10x. Then we cross multiply this way, and we get 2 times 20. And we get 10x equals to 40. And then we just solve. It's really a linear equation, and the last step will always be divide. So how do you solve a proportion? A proportion is a fraction equals a fraction. You cross multiply and divide. So it's not like simplifying where we cross simplified. There was no equals there. Here there's an equals. We're cross multiplying and then dividing. And that's how sometimes students confuse cross simplifying with cross multiplying. When we simplify, we're dividing. But here, we're cross multiplying and then dividing. If you look in some of the beginning books for algebra, pre-algebra, sometimes they call this the butterfly method. You might have learned it that way because if you put little things like that, it looks kind of like a butterfly. But students usually just don't have trouble with proportions. The setting up takes some time. Once you get used to that, then it should be pretty straightforward. But if you have a fraction equals a fraction, you can cross multiply and divide, and that's how you solve it. So let's see what it looks like on TSI. So normally this lesson will be a little bit longer. but we're going straight to what would it look like on the TSI. These are the type of TSI type questions you would see. So there's always one proportion problem on the TSI, but there's other problems where it's kind of built in. So it could be also two problems. Sometimes they want you to compare like what's the better deal, like, and you'll see those problems. You'll see the type problems. So, and these are ones that if you understand them, they're ones that for sure you should get right as well. Proportions aren't, and so a lot of times if there's a problem, a word problem, you can't figure out what to do, usually proportion will solve it. So we want to keep that in mind. So how are we going to even know if it's a proportion problem where it's a fraction equals a fraction? Whenever they have any kind of comparison or rate, it's going to be a proportion problem in most cases. And so we'll set it up. If it doesn't work, it doesn't work, and we try something else. But usually going to give us two numbers that are related somehow, and a third number, and they want to know what number relates to that number. So you're going to have three numbers all together, and they're looking for that missing part. Here it says a worker can assemble 24 packages in 16 hours. So as soon as they make any kind of comparison, any kind of rate, think proportion. And proportion is a fraction equals a fraction. So we're talking about packages, and we're talking about time in hours. We're going to make sure that the units are the same. So just because they're time doesn't mean they're same. I can have minutes and I can have hours. I have to make sure that I convert one to the other if I want to use that. So 24 packages in 16 hours. So the top is the number of packages, the bottom is the time in hours. At the same rate, so as soon as you see that word rate, think proportion. How many packages can this worker assemble in 10 hours? So this is 10 hours, so we have to figure out, well, where is that going to go? Well, the top numbers have to be the same kind of units, and the bottom numbers have to be the same units. So this 10 has to go here, because 10 is hours, 16 is hours, those both have to be hours. So what we're looking for is the missing part right here. We're trying to figure out what's the packages. So once we get the setup, then the rest is just cross multiply and divide. So I cross multiply, I get 16x equals, and then I cross multiply, I get 24 times 10. And so when we first do the first cross multiplying, we want it to be the variable diagonal. So when I multiply by 10, I get 240. And the last step, these are linear, so the last step is always going to be divide. These cancel out, and we'll use our calculator to divide. When there's something like this, the calculator is going to be available. So 240 divided by 10, divided by 16, and I get 15. So the answer here would be C. And of course, TSI doesn't have ABC, it just has those little circles. And it has the numbers next to it, so it would be 6, 12, 15, 39. So you would circle in the 15. So how do we know when to use proportions? Whenever there's any kind of comparison. Any kind of comparison or any kind of rate is a proportion problem. A proportion is a fraction equals a fraction. The top numbers have to be the same kind of units, the bottom numbers have to be the same kind of units. Doesn't matter how you switch the units. I could put time on the top and packages on the bottom. As long as they match up, it'll still come out to be the same answer. But the biggest thing is the top has to be the same, the bottoms have to be the same, in any order. Any questions with this problem? Okay, so any comparison, any rate, they're going to give you three numbers in all. The first two are related somehow, and the last one is, they want to know what goes with that. They could use the word proportional, or they could say proportional, directly proportional, or they can say any of these things indicate that we're talking about proportions. They can say it varies proportionally, it varies directly proportionally, or they'll say varies directly. So if that varies directly or proportional or any kind of rate, you know you're dealing with the proportions. So if you have a word problem, one of your word problems is going to be a proportion. And it's also built in some other problems as well. So let's move on to number 2. This one actually came off from the College Board. They released some problems so teachers would know and students would know how are their proportion problems looking. And this is one of the ones that they released. And you can see what it looks like. It says the market price of a house in a city is directly proportional. So once you see that, you want to think it's going to be a proportion problem. Fraction equals a fraction. So price, here's the thing, is proportional to area. So we're going to have price on the top, area on the bottom. Doesn't matter the order, I could put area on the top, price on the bottom, as long as I match them up, it'll still come out okay. Okay, so the price is of a 1,500 square foot home, so that's area. Square feet is area, and we know price is money. So 1,500 has to go on the bottom, and 300. It's going to go on the top, right? We'll put that to minus itself. What's the price of a 2,000 square foot home? So that's not money, and square feet indicates area. So 2,000 goes in the bottom. And so here's what we're looking for. How much is that house going to cost if house prices are proportional in this particular area? So they released this problem for two reasons. So we can see what proportions look like. And if you multiply 300,000 times 2,000, your calculator, like we're going to cross multiply, I'm going to get 1,500x equals 300,000 times 2,000. The TSI calculator, that's too many numbers. If you try to multiply that, it's going to give you an error, or it's going to give it to you in, I don't think it does scientific notation. It's too big for it to calculate. There's too many zeros and there's not enough spaces on the display. And most modern calculators will do it, and if it's too long, they'll give it to you in scientific notation. But so how do we get around that on our TSI calculator? When I cross multiply and divide. Well, we're going to simplify before. Remember we said the idea of simplifying before you multiply? So you see these end in zeros, I can divide them both by 100. So if I divide by 100, cancel out these two zeros, these two zeros. So I'm dividing them both by 100 to make these numbers smaller. So that becomes 3,000 over 15 equals x over 2,000. And so if I multiply that, that'll fit in my calculator. And I could still even simplify further by dividing the top and bottom by 5s, but that should be enough. So if your proportion, the numbers are huge, you can simplify before you multiply, cross multiply, and divide. So that's one of the reasons they released this, to show students that sometimes those numbers are too big for your calculator, so you have to simplify before. That's the purpose of knowing how to simplify before you multiply. So we can get around that limitation of the calculator. So now I can cross multiply, and I get 15x equals, and when I multiply that, I'm going to get 6, 1, 2, 3, 4, 5, 6. That's probably the limit of the 6 million of your calculator screen on TSI. Then we divide both sides by 15. These cancel out, and x will equal 300,000. So we can see the answer is, or did I divide right? Oh, 400. I didn't divide right. 15 times 4 is 60. So the answer is this one right here.
I got it right. Let's go.